Are you ready to learn? Because my super experienced guests are ready to share some really valuable information. Make sure and listen all the way to the end to get help and support. So let's start with the best audio experience.
Hello everyone and welcome to our show. Today we discuss about data. Without data, it's hard to go ahead. Without data, you can't create successful projects. And I'm so excited to discuss this topic with Joseph Sanderson. How are you?
Doing well. Good to be here.
Yeah, big pleasure. I love learning more about data because the era of lazy marketers is dead. Today, I think without the right data, without learning customers, you can't be successful because of generic data, boring information that customers are not interested about that. Before we start, just tell more about your experience, background, and why you decided to share with us about data.
Sure. So right now, I run a data platform team at a company called Convoy, which is a late stage startup based out in Seattle, Washington. It's around 13 or 1400 person freight technology company. My team is about 20 people. It's a mix of data engineers and software engineers. And our focus is on building the data infrastructure for the organization. So what that means is we essentially provide the ways for people to collect valuable data, to store that data, and then to use that data to solve a business problem. Before this, I was working in the artificial intelligence platform at Microsoft, which also saw us working with big data, very, very large volumes, and dealing with all the cost that came with managing and computing that data. And then before that, I was doing very similar things at Subway and Sephora.
Nice. Love it. Okay, let's talk about the main question: how to collect data. Because I often see when webmasters companies have the same issue, they just use I don't know, like online studies, tools to get generic data. But customers are different, and we can't use the same data for different projects, even if they have similar products. Sorry about my cat. Okay, can you tell how to collect data today?
So there's a few different ways of collecting data today. The most common way that I think most marketers are familiar with is through a website-oriented tracking tool. So this would be something like a Google Analytics or maybe Segment. The way that those work is that you have some JavaScript or some library that your software developers would use. You implement these applications, connect them to your website, and then Google has some out-of-the-box metrics that they collect about every single visitor that hits your site. So they track the number of total visitors that you get, how many times they look at pages, what they click on, et cetera, et cetera. And there's a pretty large amount of customization that goes on within those tools where you can emit events directly when things you care about happen on the website. So maybe you want to track every time someone opens an ebook or downloads an app. Those are all things that you can do directly through the website itself. But there's another category of data, which is what I focus on primarily, which we call first-party data. And first-party data is data that is collected about our businesses using our the software engineering tools that we have available. So Hoy has a front-end application, and in that front-end application, there's lots of data that's surfaced to our customers. We store, their name and the types of shipments they've taken in the past. We show them a bunch of different data about shipments that they can bid on in our app. So, what was the shipment name and the shipment type and the price of the shipment and who's bid on it. And all that data has to come from somewhere. And usually that's what we call operational data that is stored in a database. It's all pretty technical. It's in the back end, but there's an enormous amount of data that's stored in databases. It's extremely, extremely important. And in most cases, marketers don't have access to that data, even though it contains some of the most valuable data in the company. So it's information on whether a purchase was actually margin positive. The next thing that you have, and the last thing, is what we call our cloud data or our warehouse data. And that's when you have a bunch of raw data about our application, such as the purchases that someone's made, that is put in one place. And then it's transformed oftentimes for the purposes of financial reporting, data science, or product analytics. So people will combine data from many different places, and they'll use that to create important metrics. So in Convoy, one of our most important metrics is whether or not a shipment was on time. We're not capturing that data explicitly from any one place. We're combining a lot of data from many different places, like what time the shipment left, what time they were supposed to leave, what was added to the actual contract, combining all that data together into a single metric, which we then make available to our product managers and marketers.
Nice, love it. Okay, let's talk about combining data. For example, if I get the first part data, a lot of data, but how do I know which data to use? For example, tell about technical aspects to filter out data, to take away necessary, I don't know, like important data or something like this, and combining them, because you mentioned this word, to combine data and to leave just important data.
Yeah, so in order to combine data together, typically requires a analyst or a data scientist or anyone who is pretty deeply familiar with a language like SQL, which allows you to query a database. And using those languages, then you're able to write queries, and those queries allow you to merge data sets together. So it's one reason that I always recommend marketers get at least somewhat familiar with SQL, because that way they're able to go and access a lot of this really critical data. And if they can't find anybody to join it themselves, then they can do it to answer some very specific problem. The place where you join this data, there's a lot of places where you can do it, but it's increasingly common to do these types of transformations or aggregations, as we call them, in somewhere called the cloud data platform. So if you've heard of companies like Snowflake or Databricks, these are pretty common cloud data platforms that people use. And so what those are is we send our data out to something like Amazon S3, which stores almost all the data at the company. The cloud platform allows anybody to access that data and to use SQL to transform it into something that they can use to answer a problem.
Yeah. Let's talk about AI. You mentioned that you use AI. You have the experience on Microsoft by using AI. Can you tell how AI can help to find the right data? What kind of tools do you use? By collecting this data with AI.
Yeah, so it's sort of the opposite, actually. AI can't really help you find the right data, but if you give AI the right data, then it can help you uncover some really interesting things about your business. AI, generally speaking, is a statistical model. And those statistical models can be very simple, like a linear regression, or they can be incredibly complicated. But what every model is fundamentally designed to do is take in some amount of data and then use it to make a prediction about the future. So as an example, at Convoy, we have a machine learning model that is designed to predict whether or not a shipment is going to be on time. And you would think, well, why can't you use the Google APIs and look at the traffic and make a prediction based on that? Well, the reason that we can't is that freight is very different from regular traffic. The facilities are different. Sometimes a facility can have a really long wait time. Driving the truck is oftentimes different, especially if there's bad weather conditions. So the way that we make those predictions is we collect data about the weather. We collect data about the shipment and the data on the trip. We collect data about the facility. And we collect data from a bunch of other different places, including our app, which sends a ping every couple minutes or so that a driver is live and taking a shipment, and that updates our model. We collect all this data in one place. We transform it into a shape that our model can use. We put it into one table, and then we train our machine learning model, and our machine learning model gives us a prediction about whether we think any one shipment is going to be on time or not. And if it's going to be on time, then we can put that data into our app. We can let all of the shippers know, hey, your shipment is going to be on time. Everything's good. And if it's not going to be on time, we can let them know, hey, your shipment may not be on time. It might be around 30 minutes late or 45 minutes late. And here's what we're going to do about that. So AI can be extremely, extremely useful, but the backbone of artificial intelligence is actually having the right data to power it.
Nice, nice. Okay, let's talk about how is it accurate, this data? For example, I'm using some AI tools to predict stocks price, crypto prices. It's not accurate. In most cases, it's better not to use them at all. To learn from some specialists who can predict this price. What about accuracy data by predicting like shipment?
Yeah, well, anytime you're using AI to predict something that's outside of your control, like really the whole value of a tool like machine learning or AI is that you're probably not going to be correct the first time that you use it. But the power of these models is the more data that you get, you can compare the ground truth against what you predicted, and your model can learn, meaning it can update its prediction, say, oh, I was wrong by this amount, and here's the reason why I was wrong. And that reason comes from the data itself. So maybe I predicted that the shipment was actually going to be 20 minutes early, but it turned out to be 45 minutes late. So when the model gets the updated data, we can say, hey, you were wrong about that thing that you just predicted, and you need to update your thinking. So anytime where you have the ability to collect new data, give it to the model, and retrain it so that it can update its thinking, the better it's going to be. And that's exactly what some of the top like stock traders actually do. Very little of trading these days is model driven. It's just that these models are incredibly, incredibly complicated. They're also proprietary and they're built in-house. So no one else has access to them besides these large companies. So if you have the ability to do that, I think it's a really great thing to do. You just have to acknowledge that you're probably going to be off by some degree. There'll be some margin of error in the beginning, and then over time you'll become more accurate.
Yeah, awesome. Can you tell about running experiments or testing, by collecting and analyzing how this data works? Because, for example, I often use testing in my projects because nobody knows what actually works. It depends on many factors. But can you tell about testing in your niche?
Yeah, so experimentation is a very, very old discipline. It's something that was happening hundreds of years ago in an informalized way. And in the last, maybe 120, 130 years, it became a lot more formalized as a part of the scientific process. And an experiment is essentially the act of comparing a control group against a treatment group on some metric that is extremely meaningful to you or to the business. As an example, at Convoy, we might be trying to see if new features launched in our mobile application targeted towards carriers who take shipments, right? They're like the truck drivers. We'll get them to take more valuable shipments for Convoy. So one feature we might care about is the ability to leave ratings about facilities for other truckers. So they might say, well, this facility was amazing. It was extremely easy to get in and out. I'm going to give this 5 stars. Whereas another person might say, this facility was terrible. It was really difficult to get in and out of. I really don't recommend taking loads going to this facility. And in that way, we could help people make better decisions about the shipments that they take. And our hypothesis is if you have more information about, how your shipment's going to go, then you'll take more of them because you won't be disappointed by bad loads. That's our hypothesis. The way that we actually test that hypothesis is through software and it's through technology. So we will have one group of people that we call a control group, and we have to randomly allocate those users into that control group. So let's say we have 1,000 users, 500 of them or close to 500 of them will see the original experience. That means the state of the app before we launch the feature. Nothing will change for them. For the other 500 that are randomly allocated, we'll show them the new feature, the brand new thing that we're launching that allows them to, rank a facility. And then we'll let people have those split experiences for about 2 weeks to 1 month. And that depends on how many customers you have, aka how large is your sample size. The basic rule you can think of is the bigger your sample size, the shorter amount of time it actually takes to complete your experiment. And once we have enough data, then we'll choose a metric that's really meaningful to us. So in this case, it would probably be something like, the number of shipments that are taken, the number of high value shipments that are taken, how quickly somebody accepts or is willing to bid on a shipment, et cetera, et cetera. And we'll try to see if there are any significant differences between the control group and the treatment group. Now, if you're just doing one experiment at a time, or you're doing it on very small data, and it'll take you an enormous amount of time to finish that experiment, that type of science isn't really that useful. I think there's a lot of other valuable things that you could do to make decisions using data. But if you're a company like Google or Microsoft or Convoy, where you've got, tens of thousands or millions or hundreds of millions of customers, it's a great way to really quickly and accurately quantify how impactful any new potential features are.
Yeah, valuable, interesting. I have the question from my community. What are the biggest struggles in data collection?
So I think there's a lot of struggles, especially from the marketer side of the world. The one that I hear most frequently is that the type of data that we need is very, very challenging to acquire. And there's a couple of reasons why this is true. The marketing team usually sits in a place that we call downstream. So it sits very, very far away from the team that is actually generating the data. And that's because the teams that are generating the data 99% of the time are software engineers, and they're generating that data for what we call an operational use case. So to expand just a little bit on that, if you open up Facebook or Google or WhatsApp or whatever your favorite app is, you're going to see information about your profile in that app, right? I open up Facebook and I'm going to see my username. I'll see all my friends, all of the posts that I've ever made, et cetera, et cetera. All of that is data that gets stored in a database. And when I log into an application, what that application does is that it reaches out to that database, which has all the information about me. It has a user ID that is specifically associated with my account. And it says, hey, I need all of this data about Chad so that I can put it into the website. Now, that data is incredibly useful for analytics and marketing and machine learning and everything else, but it was mainly implemented so the app could function. Now, if you're a marketer and you sit way far away from the software engineers who implement that data, you might also really care about it. That data might be meaningful to you. For example, if you're using Facebook, you might want to know how many times someone clicked on an ad while they were using the Facebook platform, right? Or how much time they spent looking at an ad before they clicked it on the Facebook platform. This might all be really important information that a software engineer would have to implement. But if no software engineer has implemented it because it's not critical to run the application, then a lot of times that data will just not exist for marketing purposes. So that's a really, really big problem, is establishing that great collaboration and communication between the marketing team and the software engineering team that's actually retrieving the data. The other big problem that I've heard is that it's really hard to work with the data. So even if we've got a bunch of data that is available that represents all of the information that a marketer cares about, it might be stored in a way that's really messy. It might not be clear what this data is. It might not even be clear sometimes how the actual business works under the hood, because our software engineering systems are so complicated, and that makes it difficult to answer questions that we think are very simple. So I'll give you one example of this at Convoy. A marketer might want to know, what is the total amount of bids that have been made in our auction environment? And so to look at that, they might want to collect some data about from our front end application around how many times the bid button was clicked. That seems pretty reasonable. But it turns out that someone can actually bid on an auction without having clicked the auction button. They can do this through APIs. They can do this through other backend features. Sometimes we actually have a contract that you can sign, basically a feature that a shipper can upgrade or a carrier can upgrade to, where we auto bid on a auction on their behalf, and that's all done by a machine, and no one clicks that button. So if you compared the true number of how many bids happened to the number that is being recorded from the front end application of people just clicking, they would be massively different. And that would be a great example of people just not having enough information to make the correct decision on a question they have.
Yeah, interesting. You mentioned about the struggle between, I mean, like to unite teams, marketers, data science. I know about the struggle of uniting salespeople and marketers. Can you tell how to unite them with one cohesive goal? Because it's a big struggle, and if departments go different directions, it's hard to create great results. Tell about your experience about, yeah.
Well, the really great thing about being a marketer, and I know it doesn't always feel this way sometimes, is that the marketing team has an enormous budget. And the reason the budget is so large is because your work contributes directly to making money for the company, right? If you spend $1, then you're expected you'll make, $1, you'll make 50 cents, or you'll make $2 or whatever it might be. And because you have a big budget, that means that you have a lot of influence and say within the organization. So the way that you wield those resources can be the difference between success and failure in this area. What I recommend everyone do in order to begin creating that great collaboration is focusing on something called events. So an event is basically a single moment in time where something happens to a critical entity in the company. So I'll give you a couple of examples of this. An entity might be a customer. It could be a person who is using a e-commerce website, and or it could be a shipment. It's really any noun that you can think of. So let's say that you are running like Amazon.com or something like that. You might have a bunch of entities. An Amazon Prime account could be an entity. A user could be an entity. An item in the store could be an entity. A shopping cart could be an entity, and so on and so forth. Now, in order to understand how these entities behave, this is where we record events. And events are like verbs. So at Convoy, one of our really key events, one of our core entities is a shipment. And shipments are created by shippers. They're put onto a marketplace. They are bid upon, and then they are released, and a carrier might take them to a facility in the physical world. And there's a lot of stages of that process that a marketer might really care about happening. For example, they might want to know the moment that every new shipment is added to our marketplace. They might want to know how many bids each shipment has, whether or not the shipment was canceled en route. They may want to know how quickly that shipment was actually fulfilled, right? This is all information that you can put into your marketing materials as one example. But the only way to get that data is to have a conversation with your software engineer. The good thing about framing this problem as events is that it makes it easy for the software engineer to figure out what to give you. And the easier that you can make it for them to figure out what to give you, the better relationship that you're going to have. The way that you structure an event is you essentially say, here is the entity that I care about. This is a shipment. Here is the definition of this behavior. Let's talk about the shipment cancellation event. So I want to know every single time that a shipment is canceled, either in our website or using our API or in our mobile application. And here's all the data, the additional data that I want to know about the shipment at the point it was canceled. I want to know the time it was canceled. I want to know the reason that was given that it was canceled. I want to know who canceled it. Was this the shipper who owns that shipment? Was it the carrier who was taking that shipment, or convoy? How much money would we have made on this shipment? And so on and so forth. So if you provide that data to an engineer, we call that a schema. Then the engineer is going to be able to more easily implement and get that data for you on your behalf. If you just go to an engineering team or a data science team and you say, hey, I need information about shipment cancellations, and I need to know X, Y, and Z, it's going to be really hard for them to formulate that into an ask that they know. Basically, they can't read your mind, and it will be challenging them to figure out exactly what they need. And if it seems like a very hard problem, they're probably going to put it at the bottom of their priority, which means they're not going to do it, right? So the clearer and more constrained that you can make all of your asks for data, the more likely it is that they'll actually be fulfilled.
Yeah, valuable. Okay, let's talk about the balance between traditional data and AI data, because I'm not sure it's a good idea to rely 100% to AI data. Sometimes even CEOs of big companies, I remember CEO of Pepsi shared how he can go to the customers to speak to them, to learn from them. They can open social media groups to learn from customers. Can you tell from your experience how to find the balance between manual job that you can speak directly to customers or salespeople who sell them, and by using AI data that can collect from various resources?
Yeah. So yeah, it's a really good question. I would say that talking to customers is always going to be your best source of data, especially when you're trying to go from 0 to 1, right? So 0 to 1 is you have nothing, or you're working on a brand new feature, or you're entering a new product space. There is no amount of artificial intelligence that is going to be able to help you do that. That will require a human brain talking to people and understanding patterns and potential problems. So that's one area where artificial intelligence really does not help that much. Where AI becomes very valuable are those areas where you're operating at scale in a way that people can't manage. So, for example, Convoy wants to predict whether a shipment is on time for tens of thousands of shipments every single day. We just don't have the manpower to actually do that, right? We can't hire someone to sit in a room to make predictions about whether or not shipments are going to be on time. They'd go crazy. So that's the perfect job for a machine. Similarly, Convoy has an algorithm to predict what the freight market is going to look like every single day. And that actually helps our salespeople decide how to price the shipments that we bid on for other companies. This is another thing that would be incredibly hard for a person to do, to make daily highly accurate predictions. There are still people in the loop that look at this data that then AI generates. So a person has to sit down and say, does this make sense, knowing everything I know about the market? But we combine so many factors that we provide a new level of insight that an individual person working alone is probably not going to be able to generate. So those are the two use cases where it becomes really, really important. Either we're doing something a human is not able to do, or we're doing something where a person needs to work in the loop with that machine learning model. We're essentially augmenting a human's capabilities. Where I would say is that everyone needs to start by talking to your customers. That's something that should be happening every single day, multiple times a day. It is going to be the best source of your data. And that's because the final reason, machines and artificial intelligence can only detect the data that is already there, and you have the ability to collect systematically. So for example, for every single shipment that comes into our system, there might be 10 or 20 properties that we are collecting based on our software engineering team, right? We're collecting who is fulfilling the shipment, who asked for the shipment, the shipment starting location, the ending location, the contents of the shipment, how much the shipment costs, and so on and so forth.
Yeah, awesome, awesome. Okay, I have the question about must-have. I'm interested, for example, what all companies need to do, like a must-have today, from your experience about collecting data.
So in terms of must-haves, I would say the must-haves are like I was saying before. You need to start off by just capturing heuristic data and basic data through conversations. If you don't have that, that's the number one place to start. It's going to deliver the most value. The next thing that I would do is use something called an ERD. So an ERD stands for an entity relationship diagram, and it looks like a graph or a map of all the important nouns and verbs in your business. So these are the entities I was talking about before. And what this graph essentially tells you is, how does your business work? Where does data start from? Where does it flow to? How do these different objects and entities interact with each other? And based on that map, then you're able to see, where do we have a lot of data? Where are we missing data? Where are there like big holes in our knowledge that are super important? And then you can go out and get that information. Oftentimes teams are flying totally blind, and so it's really difficult to know, where data is missing and where it's not missing.
Nice, nice. I remember when Bill Gates shared what to learn today, according to modern society, and he replied, AI. It's better to learn AI because it's the future. I think it's the present as well. Let's imagine you have no experience, knowledge, skills, no Microsoft experience, anything. What will you do today to learn more about AI?
So the best thing to learn more about AI is to go work for a company that's using AI. If you want to learn about the technical implementation of AI, so if you want to be a computer scientist or you want to be a machine learning engineer, then of course I would recommend, going to school and taking some classes and getting a degree, because those are very deep, very advanced fields. But if you're a marketer and you want to learn how to use AI for a particular use case, go work for a company that is well known for using AI, and there's going to be frameworks and processes in place that will allow you to understand how AI is used. AI is used extraordinarily heavily at Convoy. It's used everywhere, from our pricing model to our shipment predictions to predicting the freight marketplace to many other areas. It's sort of a first-class citizen at the company. And so if you as a marketer went to Convoy, we've got a lot of processes and frameworks for understanding how we collect data, how that data is used, how the machine learning model is applied. And you can begin to think about applying machine learning for your own use case. A lot of times people try to learn AI at companies where it isn't being used. This is an incredibly difficult thing to do, because you essentially have to learn all that information yourself. You don't have any foundation that you can pull from. You don't have anyone that can help you or teach you this. So if you're focused on the skill set and you're not focused on, staying at one particular company, then my recommendation by far is to just go to a company that's using AI and learn from them.
Nice, nice. You mentioned many times about Convoy. Can you share your unique selling proposition? Because we have many different other companies. And can you tell what kind of customers you have and why you are better than your competitors?
So Convoy is a digital freight marketplace, which is very different. It's one of the only digital freight marketplaces in the entire world. And what that means is we facilitate shippers pushing their shipments that they want fulfilled into our marketplace. And then our carriers who take shipments can then bid on those shipments as part of an auction. And then we track the process of them actually picking up that shipment, delivering it, whether it's on time or not, and doing a variety of other things. The fact that we are using a marketplace is really, really unique. There's only one other major competitor in the United States, which that's doing that, which is Uber Freight. And the benefits of that system is that we have an enormous amount of data. There's so much information we have on people's bidding patterns, on pricing, on how whether or not facilities are performing as expected, and we can give that data to our customers on both sides, either on the shipper side and say, hey, there's some facilities that you own that are not performing well. Here's where we've noticed they're not performing well, and here's how we think you can improve. Or we can give that data to the carriers and say, here's a lot of opportunities that you could have bid on that you missed, or here's opportunities where your drivers were late, and here's how you possibly could have improved that, so that you're not going to get rejected by those shipments from those shippers in the future. So it's really our data and providing data to customers on both sides of the marketplace that makes it a compelling alternative.
Nice. I have the question about, for example, in marketing, we often use AI tools to generate text. Even the last time we can generate pictures. But if I compare text to great experts who can write awesome, valuable text, AI is not ready, to beat them, to overcome them, because of many things. I don't know what kind of future will be, but today texts are not good. Sometimes I think AI can beat like mediocre writers, but not experts. Can you tell from your experience what AI is not ready today to compete with human beings, and where it's a must-have and you can't avoid it?
Yeah, so I kind of talked about this a little before, but it really, anything that requires a lot of creativity, human creativity, and artificial intelligence is going to struggle. Because again, like the way that an AI system works, it's actually on its face, it's actually very simple. There's a lot of complexity that goes into the infrastructure and the actual application of science, but on its face, it's very simple. You have some data, some structured data or non-structured data like images or something else. You feed it into a statistical model, and then you use that data to make predictions about the future. Now, the artificial intelligence is going to be limited on those predictions based on the data that it receives. So let's say, I'll just give you an example of this. Let's say that we've taken 10 total shipments at Convoy, and those shipments are all have a starting destination of Miami, Florida, and they all end in Atlanta, Georgia. And every single one of those shipments is being offered by the exact same shipper. And we'll say that's Niagara Water. And because of that, we have a contract with Niagara Water that states that no shipment they offer us, we are going to pay more than $500 for. So every shipment is going to be $500. If we train our machine learning model on that data, it is going to come to associate Atlanta and Miami and a $500 shipment with any shipment that is starting from Atlanta or going to Miami. So if another shipper comes in and says, hey, I have a shipment for you, and it's also going from Atlanta to Miami, the model is going to predict like the price of that shipment will be $500. That's the only thing it knows, because that's the only information that it's been given. But we don't have a contract with that company, so it could really be $1,000 or it could be $2,000. The model has absolutely no way of knowing that. And that's exactly what happens when it comes to like content writing or art or web design or anything like that. You can feed a model all the data in the world, but if you're creating something new, something unique that the model has never seen before, then it's going to do a pretty bad job. Now, as these models that you guys are using to write content improve, meaning as there's more data that feeds into that model, and the model is able to cover a wider variety of use cases, maybe it'll get to a point where it's just as good as a more senior, more technical content writer. But I think that time is still a pretty long ways off. The best use case for AI and ML is when you're trying to operate at a scale that a human physically could probably do themselves if you hired a bunch of people, but you just don't have those resources. So I'll give you an example of this. I might have a mobile app that allows somebody to upload a picture of a bird, and my application will tell them what bird I think that is, right? Now, it's probably not possible for me to have a bird expert that sits at a computer all day, and every time a new picture is uploaded, they type in, oh, I think this is a red-tailed dove or red-tailed hawk or whatever, right? You're going to be getting hundreds of thousands of pictures every single day. A person just can't do that. But if you have data, if you're able to train that machine learning model on every single type of bird and all their pictures, you can give it to a model and one machine can make that prediction for 100,000 people quite easily.
Nice, nice. Chad, I have the final question. You mentioned a few times that AI can predict the future. Please provide your forecast. What kind of future will be in collecting data?
Yeah, that's a good question. So I think that machine learning and artificial intelligence is going to become certainly a backbone of the technology industry. There's going to be a lot of use cases for AI machine learning, and I think that it is going to be hugely beneficial to anyone in the technical space. It's going to augment our work. It's not going to detract from our work. I think that's something that's coming and it'll probably happen within the next 10 years. I also think that our ability to collect data is going to get much, much better. And the quality of that data is going to go up. And it's going to be easier to collect the data that we want. So there'll be tooling and technologies that come out which make data collection trivial. I think the other thing that's going to happen is we're going to start to see the rise of artificial intelligence-driven root cause analysis on the data that we own. Meaning if we have data coming in from everywhere, so at Convoy we have data about shipments and data about our customers and data about our facilities, what we'll be able to do, what artificial intelligence will be able to do is look at the patterns between those concepts and see what was the root cause for certain things happening that any individual human wouldn't be able to detect ourselves just because it's too much data to actually go through. So we might be able to figure out, and AI could detect, the reason that a facility started performing poorly on Wednesday is actually because we experienced a lot of new shipments from a certain customer that clogged up that facility on Monday, right? And AI would be able to detect that where it might be really challenging for a human to make that connection.
Nice, nice, awesome. Chad, tell our audience how they can reach out to you, learn more about you, follow you.
Yes, so you can follow me 2 places. I have a LinkedIn, it's just Chad Sanderson on LinkedIn. I recommend everybody follow me there. I post a lot, I'm very active. And then I also have a newsletter on Substack, and that's dataproducts.substack.com, where I write about data and machine learning.
Nice, nice. Guys, you need to follow Chat. You can see a lot of valuable insights. I follow. It's better to, you can find these links in the description below. Listen us on Apple, Google, Spotify. Thanks again for your time. A big pleasure. Welcome back anytime back to share more value. I love it, guys. You need to follow Chat. You need to open his LinkedIn. You need to check out about company Convoy because you can see a lot of unique selling proposition there. Okay, guys, love you. See you.